Okay, this is Xiaolong. I'm presenting our work, Binge watching, scaling affordance learning from Sitcoms. So we are going to study on affordance here, which is defined as how humans interact with the scenes. Given an empty location in the scene, we want to predict what is a reasonable pose when there is a human. For example, we want to predict poses sitting on the couch or poses walking down the stairs. However, unlike standard tasks such as classification or detection, there's not a large-scale dataset for affordances. There are many two ways to collect the data. The first way is via human annotations. For example, here, the green pixels represents the places humans can sit on. However, this is very time-consuming. The other approach is via geometry simulations. However, this often leads to physically plausible but not common affordances, such as humans sitting on the stove. In this paper, we're going to collect the affordance data by watching TV shows. Our algorithm scans through 100 million frames in 7 TV series, and we collect 28,000 poses in 10,000 scenes. Before showing how to collect the data, I would like to first show you some examples. We can see we can collect all these poses walking down the stairs or walking towards the bed and sit down. There are many two ways to collect the data. The first way is via global matching. Given an image of an empty scene, we perform image retrieval to obtain all the images of the same scene but with more people. We perform pose estimation on these scenes and project the poses back to the query image. The second way is via local matching. Given the empty scenes, we perform pose tracking on the one person on the following frames, and then we project all the poses back to the first frame. Now we can see the poses is working in the empty room. Now, given all these poses collected by our algorithms, we have 28,000 poses and in 10,000 scenes, we can start training neural network on top of it. We want to train a model to predict the human pose given the empty location in a scene. We propose a two-stage method by first perform pose classification and then estimating the scale and local deformations. So in the first stage, we first perform pose clustering and cluster all the poses into 30 clusters. And then given the image and the location as input, we train a CNN to predict one of the 30 pose clusters. For example, here we have a corpse sitting pose. On the second stage, we use a variational autoencoder. Given the images and the corpse pose as input, we can basically perform sampling on the latent variable z and generate the pose scale and deformations, which are used to further refine the corpse sitting pose. Here, the following are some results when we test our models on the Friends videos. We can see there are all kinds of poses, like poses sitting on the bed, walking on the floor, or reaching the tables, and sitting on the couch. They're all acting very naturally. Besides these results, we also show that our model can generate different poses on the same location of the scene by sampling the latent variables in VAE. For example, here, we can see the poses is interacting with the random machine in two different ways. Now let's see how this method can help tasks like pose estimation. Given the pose estimation results on the left with some missing joints, we can basically estimate our affordance poses in the middle. We combine these two predictions results, and we can recover the missing joints in pose estimations. Finally, I would like you all to please visit our poster for more details. Thank you.